All right, guys, welcome back. I'm so happy. We finished first unit already. We're moving on to second unit. How exciting. I hope you had I hope you had fun watching my video for the first unit. Hopefully we'll enjoy the ride once more for unit 2. All right, so unit 1 was about polynomial functions. In unit 2 we are going to look at two different functions. One is called the absolute value function, which is what we're doing today. And the next two lessons are the reciprocal functions, okay? So let's start with absolute value functions first. I believe in pre-calc 11, you talk about or you learn about absolute value. So if you don't remember, we'll just quickly look at what that is. So remember, absolute value is basically an operation that makes everything positive. Okay, so for example, absolute value of -5 would equal to 5. And for example, the absolute value of 5 will remain 5. Okay, now this, I don't know if your pre-calc 11 teacher mentioned this to you. Absolute value function usually can be written in a piecewise notation. Okay, I will show you this because you'll need it in calculus really. So show you f of x. Let's say, okay, hold on, f of x equal to absolute value of x. Okay, this can be written in a piecewise notation. It's either positive x or negative x. Now think about this. If x is a positive value, okay, if x was positive, then really the absolute value of x will just remain x. So it will remain as x if x is greater than or equal to 0. However, the absolute value of x, if x was negative, right? Let's say, for example, if x was -5, then the absolute value of -5 is actually positive 5. And the reason why it's positive 5 is because we can rewritten it as a negative x. So if x was negative, then really absolute value of x, it becomes negative x, right? So then negative of -5 will give you positive 5. And that's really how it works, right? So the absolute value function can be written as a piecewise notation. Okay, so either positive or negative. This number 0 is what we call the critical point, and we'll talk about that in a second. Okay, that's the critical value. Okay, anyways, absolute value function here is really it's a form. Okay, it is written in the form y equals absolute value of f of x. Okay, so that's the absolute value function. Okay, that's what it looks like. Again, the two bars, it means absolute value. It makes everything positive. Critical point is the x-intercept that will change the direction of the graph. Okay, so it's the x-intercept, x-int of the graph, and the graph changes the direction here. Graph changes direction at this point. So really what it does is it changes from either positive to negative, right? Or from negative to positive, right? So that's why I'm saying this is the critical point, because you can see when x is bigger than or equal to 0, it's positive x. If x was less than 0, then it becomes negative x. Okay, so at 0, that's where the graph changes. So that's what we call the critical point. Okay. Okay, so we will do something simple first. Okay, a linear function, and we're going to be looking at the absolute value of a linear function here. It says sketch the graph of y equals absolute value of 2x minus 8. We want to identify the intercept, the domain, and the range of the function. Okay, so I am going to draw the axes first. Here is my y-axis. Okay, so here you can see if we just look at this, what it's saying is f of x is 2x minus 8, right? So what we need to do first is to draw this first, okay? Draw draw 2x minus 8 first. Now, this is a linear function, so I know the y-intercept is negative 8. So I am going to draw my x-axis a little bit higher than usual, I guess. Let's say here, that should be enough. Okay, so here's my x-axis and here's my y-axis. F of x equals 2x minus 8. So my y-intercept is negative 8. That's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's my y-intercept of negative 8. The slope of this particular linear function is 2, which means we go up by 2 and 1 to the right. Okay, so from my y-intercept, I go up 2, 1 to the right. I go up by 2, 1 to the right. Up 2, 1 right, up 2, 1 right, up 2, 1 right, and so on. Okay, and then normally it will bring a ruler. It's not an easy thing to do on the screen, so I'm just gonna freehand it. There we go. So there is my y equals to, or f of x equals 2x minus 8. Okay, so there is my f of x. However, the question was not about f of x. It was about the absolute value of f of x. So we can find a critical point. Critical point, remember, is the x-intercept of the graph f of x. Now here, our x-intercept is 4. Okay, so this is our critical point, which means the graph will change there. Okay, so what I'm going to do is I'm going to use a different color, and I'm going to draw or put a dot there at positive 4. Now, if you think about what absolute value means, okay, absolute value simply means when it was negative, we're going to make it positive. So same thing, on the graph, when it was negative, we are just going to flip it over to make it positive. Okay, so you can see this point right here is negative 2. So because of the absolute value, we are going to make it positive 2. Okay, we simply flip over. This point right here, the y value is negative 4. So what we're going to do is, instead of putting negative 4 here, we're going to flip over the x-axis and then put a positive 4 there. So these points became the red dots. Okay, so then we will join them. Okay, and of course this continues with the other points, but as you can see, I'm running out of the room. So there is my, okay, I kind of didn't go through the point. It bothers me a little bit. Okay, let me just, there we go, that's better. Now you might think about or ask about, what about this part? Well, that part was already positive, and remember, when we take the absolute value of a positive number, it remains. So for the graph, for the absolute value of f of x, really this part remains. So the red part is the solution to, or it is the graph for, so I guess let me write this in red. So if we were asked to sketch this graph, that would be the answer. You don't need any part of the blues. Okay, so it's just the red part. So this portion. Okay, because that is the absolute value graph. Okay, now we are also asked to find out the domain and the range. So domain, remember, is the possible values of x, and based on the graph, you can see it keeps going to the right, it keeps going to the left. So really, there's no limit or there's no restriction for the domain. So it's just x all real numbers. X is the element of all real numbers. Range, however, because it's absolute function, you can see there's nothing below 0. So in this case, the range will be y is greater than or equal to 0. Okay, it could be anything greater than or equal to 0, but not less than 0. It could be 0, but not less than 0. Okay, so that is the intercepts. Oh, I guess we need to identify intercepts. So here the x-intercept would be 4, 0. The y-intercept, well, the y-intercept of 2x minus 8 was negative 8 here. This was the y-intercept, right? Now again, because of the absolute value function, we're going to flip over. So now the new y-intercept is going to be at 0, 8, because this was 0, negative 8. And we are going to flip over the x-axis. There's a reflection over the x-axis. So then it became 0, 8. Okay. All right. So that's the linear function, I guess. That's the absolute value of a linear function. That's the first example. Second example, we are going to be looking at the sketch of a graph of absolute value of a quadratic function. Okay, so I'll do this one and then I'll let you try B. Okay, it's actually very similar. Okay, so first, again, the first step is to draw y equals negative 2 bracket x minus 2 squared plus 3. So draw the inside function first. This is a quadratic function in the vertex form, and we know that this graph opens downwards because the leading coefficient is negative. We know so it looks like this, and then we have a vertex at 2, 3. Okay, 2, 3. So then we can draw. Okay, we can draw 2, 3. So I guess it's on the right hand side. I'm just gonna do it here. Doesn't matter. One, two, 1, 2, 3. So here's my vertex. Okay, here's my vertex. I can find my y-intercept quite easily. Okay, so I will do that. Y-intercept is gonna be so you put in 0 into x and plug it in. So y-intercept is 0, comma, what is this? That's negative 5. So 0, 1, 2, 3, 4, 5. We also should find the x-intercept. Well, it does ask us to find the intercepts. So the x-intercept in this case, I don't think it's going to be a nice number. But to find the x-intercept, recall what we do is we put 0 into y. So we say 0 equals negative 2, x minus 2 squared plus 3. Moving the 3 to the left and divide both sides by negative 2, you should get 3 out of 2 is equal to x minus 2 squared. Square root both sides, you get the square root of 3 over 2, positive or negative, is equal to x minus 2. So solve for x, you add 2, so 2 plus minus root 3 over 2. You put this into calculator, you should get, I don't know, let's put it into calculator, 2 plus square root of 3 divided by 2. You should get approximately 3.22 or 0.778. So okay, so the graph is a bit small here, or the grid. Okay, let's see. 3.22 will be right here. Close enough. 0.78 is somewhere here. So, and we know it's symmetrical, so we know if we have a point here, that means we will have a point right here. Okay, symmetrical. So there is our graph for f of x. Now, of course, it asks us to sketch the graph of f of x. We are actually going to graph the absolute value of f of x. So then again, all we need to do is to flip the negative portion, and we keep the positive portion as it is. So right now we have 2 negative points that's labeled on the graph. Those are the y-intercepts. That's 1, 2, 3, 4, 5. So we're just going to flip over so that you can just count really. 1, 2, 3, 4, 5. Therefore, 1, 2, 3, 4, 5. So here is my new y-intercept. Again, same thing here. If we're going to, this distance is 5. That means from the 0 to the positive side, this is also 5. So the graph will then look like this. Okay, I should probably zoom this in a little bit more. It looks like this. It didn't go through. There we go. And this portion will remain the same because they were already positive. Okay, so that part is not going to change. Okay, that part is not going to change. There we go. Looks something like that. It's a W shape, I guess. And you don't need, you should cross this part out, right? Okay, that's no longer part of the solution. Okay, so that's the graph. Now again, we are looking for the intercepts. The x-intercepts would be the same. They will not change. So I'm just going to write as an exact value. So 2 plus minus square root of 3 over root 2, or square root of 3 over 2. The y-intercept is no longer negative 5 because we flip over. So the y-intercept is now 0, 5. Domain, again, the graph keeps going left, keeps going right. It's all real numbers. The range, you can see it's bigger than equal to 0. Okay, so I'm going to pause the video. Okay, I'm going to zoom out this a little bit here. I'm going to pause the video. Okay, and you can try part B and see if you can do it. Again, the first step is to draw the inside function, 2x squared minus 8. Good luck. Okay, so let's come back to this. I'll do it quickly. I'm assuming you already finished. Okay, so here, first step is to draw 2x squared minus 8. I can find my y-intercept easily. This would be negative 8. I can find my x-intercept here as well. I believe it's plus minus 2. Okay, you just make y 0 and solve for x. Okay, you know what, I'll do it. So 0 equal to x squared minus 8. So move 8 over, divided by 2, you get 4 equal to x squared. Therefore, x equal to plus minus 2. So we are going to draw this graph right here. Okay, so hopefully okay, one more line down. There you go. Okay, so my y-intercept is negative 8. That's 1, 2, 3, 4, 5, 6, 7, 8 right here. Perfect. And then my x-intercepts are 2 and negative 2. So that's 1 here and 1 here. So here is my sketch of the parabola. Oh, by the way, I know this is my vertex is because this really is just the transform. I mean, you can rewrite this as y equals 2 x minus 0 squared minus 8, right? They are the same thing. So you can see the vertex is 0, comma, negative 8. Okay, so this is my graph of 2x squared minus 8. Now, if we want to draw the absolute value of this, again, all we need to do is to flip the negative portion. So here is the negative 8. If we flip it over, it becomes positive 8. 1, 2, 3, 4, 5, 6, 7, 8. That's right here. So then it's just going to go up. And then it's going to go down like this. This portion is not going to change. So that is still going up like this. And this is still going up like that. So it's a W shape like that. Okay. So then quickly we can find the x-intercept and y-intercept. So again, this portion should be crossed out. Okay, x-intercept do not change, positive, negative 2. Y-intercept, hold on a second. Okay, I'm back. Okay, so y-intercept would then just be 8. Okay, so this is 0, 8. What else? Domain and range. So domain, again, it keeps going on the left and keeps going right. So it's all real numbers. Y is greater than or equal to 0 for the range. Okay. So that's how you do absolute value functions. Okay. You basically take the negative portion and you flip over x-axis and make it positive. And you keep the positive portion as is. Okay. All right. We'll keep going. Oh, here we go. Piecewise notation. I guess I jumped the gun earlier. I guess it doesn't matter. Okay, piecewise notation. So again, this is why if we have a function, y equals f of x, absolute value of f of x. This can be written as a piecewise notation, either the positive of f of x or negative of f of x. And this, we keep it positive if whatever the x value that makes f of x positive. So if f of x is greater than 0, and this is when f of x is less than 0. But I know I'm writing as f of x greater than 0, greater or equal to 0, or less than 0. However, you need to find out what the x value is that makes it positive or negative. okay? Whatever the x value that makes the function positive would be written here, and that's our critical point. And whatever the x value that makes it negative, we then write it here, okay? So again, that's the critical point. Okay, so for example, if we want to write this y equals the absolute value of 2x minus 1 as a piecewise notation, we would then write this as equal to, okay, right, like this, y equals either 2x plus minus 1 or negative of 2x minus 1. And when do we use each of these two notations? Well, again, we keep it as it is if the function is positive. So I guess what we need to think about is, when is this function positive? For what x values is this function positive? Okay, so that really, if you think about that, really is we're looking for the x-intercept, our critical point. So the x-intercept, then we make y 0 and solve for x. So 1 equals 2x, x equals 1/2. So when x is greater than or equal to 1/2, then it's positive. When x is less than 1/2, it's negative, right? If you put, let's say, 5 into x, you can see 2 times 5 is 10, 10 minus 1 is 9, which is positive. So that's the positive case. You put it into in this first notation here. When x is less than 1/2, for example, 0, 2 times 0 and is 0, minus 1 is -1, and you can see the value is negative, and therefore to make it positive, we need to throw in this negative sign here to make it positive. Okay, I'll show you one more. This is quadratic case. Same thing. Okay, so again, this can be written as a piecewise notation. Either it's going to be negative x squared minus 3x, or the negative of negative x squared minus 3x. Of course, you can simplify this. You can make it positive x squared plus 3x. Doesn't matter, okay? If. Now, in this case, it's a quadratic, okay? So I would actually do a quick sketch, okay? It will make your life a lot easier, I think. If we make a quick sketch of this, again, the key is we need to find a critical point. This is quadratic, so we just need to factor. So we have negative of x squared minus 3x. We can factor negative x. We get x plus 3. And if we make this equal to 0, in that case, then x would equal to 0 or negative 3. So here are my two x-intercepts. Somewhere here, doesn't matter. This is negative. The leading coefficient is negative, so it opens downwards. So it looks like this. Okay, so if you look at the graph, okay, the graph is positive here. Okay, that's the positive part. It's between these two x-intercepts. So we keep the function as it is if the x values are between these two x-intercepts. So in that case, if the x values were to be between negative 3 and 0, okay, so that would be positive, right? You can see the graph. This portion of the graph is positive, and that's the domain for that portion of the graph. If it's positive, then we keep the function as it is. However, these two portions are negative. Okay, so what we need to do is we need to flip it by reflecting over x-axis. And that's why we have this negative sign. Remember, the negative sign in front of the function tells us that there's a reflection. So what would be the domain for these two portions? Well, in this part, it is either x is smaller than negative 3, or when x is greater than, that's this portion, 0. Right? That would be the domain for each of those two parts, right? Less than negative 3 or greater than 0. Okay, so piecewise notation might need to take some time to wrap your head around, but I think if you draw a quick sketch, it will definitely help. Yeah, that's it for the first lesson in this unit. Here are some questions that I think you should do. Let me know if you have any questions. You can, I don't know, show up during my office hour or something. All right, good luck.